So let's dive into first problem. Problem title is It's Time to Duel. So Move arrange the n players in line numbered from 1 to n. They then held n minus 1 consecutive duels. So for each I from 1 to n minus 1, players I face player I plus 1, producing one winner and one loser per match. Afterward, each player reports a value AFI. So AFI would be a binary value. So 0 will be indicating if player 1 and 1 indicate 0 will be indicating if player loses the duel, and 1 will be indicating if there will be a win, at least one win actually. So since some may lie about their results, reporting 1 instead of 0, to influence prize outcomes. So this guy move will cancel the tournament if he can prove any report to be false. So simply we have an array of basically a binary array. So we will be having a binary array. And here this value could be 0 or 1. 0 is representing that this guy must have competed with the next guy, which is the I plus 1th guy. And if he must have lose or must have won, like whatever would be the case, he must have reported something 0 or 1. Now this 0 or 1 could be true or could be false. Now what our task is, what we supposed to do is supposed to check whether this array, this final array that is given to us, in this array, if there exists any single guy who is telling a lie. So let's go through the test cases. So first test case is 0, 1, 0. Yeah, 0, 1, 0. So let's see if there exists any possibility. Okay, so this is the 0th guy, this is the first guy, this is the second guy. So if there exists a match between 0 and 1, and 0 must have lose with the first guy, so that's why here is 0. Okay, no issue. Here 0 can occur. Now for this first. Now this guy will be having two matches. First with this 0 and second with the second guy. So if he won at least one match, so this guy will be having two matches. If he won at least one, then he can report one. So as if here we can see it is 0, it means this guy has lose the match with this first guy. So first guy has won the match with this 0th guy. So yes, here one can be reported. Here can we Hello guys, am I audible? Hello, hello. Okay, fine. So we have seen the first test case, right? Guys, we have seen the first test case, isn't it? Okay, so we have seen the first test case. So now we are moving towards the second test case. So second test case is 0, 0. So let's see if it is possible. So there are two players, 0 and 1. So 0 must have defeated with the first guy, so that's why here we have 0. But this guy cannot report 0. So if either 0 or 1 is lying, we are not sure who is lying, but either 0 or 1. So that's why, yes, here we have at least one liar. So let's see the third case, which is 1 and 1. So this guy must have won the match with the first guy. 0th guy must have won the match with the first guy. Okay, so there is no problem with this one. But this one, that is faulty. Because there will be only one match. So there will be one win and one lose. So yes, we cannot report 2-1. So that's why, yes, we can say either 0 or 1 is lying. So that's why the output for this test case will be yes as well. Okay, so now let's come to the observation part. So guys, what you guys have observed? What let's see when we can say that there exists a liar. Let's not talk about the honest case. Let's talk about when we can say yes, there exists a liar, because we have seen 3 test cases, so we must have concluded to some observation. So what's your call on these 3 test cases? So yeah, so what we have seen, like we have seen 2 yes, 0, 0 and 1, 1, and that makes complete sense. Like, how come everyone report 1? Like, how is it possible? Like, if there is any contest and like n guys are participating and there are n wins, this is not possible. Like, this is not possible. If there are participating n persons in that tournament and there are n wins, that is not possible. So like at least one has to lose. So yes, if we have all 1 in the array, then we can report yes, there is at least a guy who is saying a lie. Okay, so that was the first observation, and that was the pretty obvious observation. Now the second one was a tricky. So let's see this test case. In this test case, 1, like 0, 1, 2, 3, 4, 5, and 6. First, this 0th guy must have won the game with the first guy. Okay. The first guy must have lose both the games. Okay. That's why here we have 0. But what about this? This guy, if this guy has lose both the games, then this guy must have won at least 1 game. So that is not true. So the third observation is, like, you cannot see 2 consecutive zeros. You cannot see 2 consecutive zeros. If you are seeing 2 consecutive zeros, it means at least one of them is lying. Because if this person has lost the game with this guy, or this person has lost the game with this guy, then at least one of them has to be won. So these were the 2 test cases. These were the 2 only cases that we were supposed to cover for the first problem. If there is an array with all 1, in that case we will be reporting yes. Or if we find any subarray or any 2 consecutive zeros, then we will be reporting yes. So that was the solution for the first problem, and that was pretty simple and pretty intuitive. So yes, that was the solution, guys. Like, I am just checking if any 2 consecutive AOIs which are 0, then I am reporting yes. And then we have to check whether all elements in the array are 1. So I am simply sorting the whole array and checking whether the first and last element of the array is 1. If that is the case, then I will report yes. Otherwise, we will be reporting no. So that was for the first problem. So let's jump to the second problem. Okay, so this problem name is Slice and Survive. So let's not read the whole problem statement. So I am telling you what is the problem actually. So guys, we have given a grid, and again, this is also an adversarial game. There will be two adversaries who will be competing with each other. So let's say this is the matrix. So in this matrix, randomly there will be a place where what exactly what, but there would be something, a sort of monster. Yes, a monster will be placed. So let's say here. So this is the 1 comma 1 or 2 comma 2, the cell number. It depends whether you are starting indexing from 1 or 0. So let's say this is the cell or any cell where any random cell where a monster is placed. Now there are two players. Let's say player A and player B. So what player A is supposed to do? What player A is supposed to do is player A is supposed to make a cut. Like let's say I am a player 1. What I will be doing, I will be making a cut to the grid, and that cut could be either an horizontal cut or it could be a vertical cut. It could be a horizontal cut or it could be a vertical cut. And I can make this cut anywhere in the cell, anywhere in the grid. And after making this cut, I will be removing the part which does not contain this master. So if I have this, it's a 4 by 4. Okay, let's see 3 by 3. And monster is placed here. Now I can make a cut to this matrix anywhere I want, but that cut has to be either horizontal or vertical. So let's say I cut this matrix from here. Now the part which does not contain the monster will be removed. It means now this part will be removed. Now the resulting matrix is this. Now there is a player B. What player B will do? Player B will be replace this monster to the remaining grid. Now it's his or her choice whether to put this monster at the situated cell, or he or she can also change the cell position. So it's choice of the opponent whether he choose to change the position of the monster or it can remain same. So now again my turn, there will be my turn. I will be again removing the part which does not, I will be making a cut, and then after making cut I will be removing the part which does not contain the monster, and then again the second player will come and he will place the cell, he will place the monster into some cell, and so on. And the game will stop because as we can see in each turn, the cell size, the grid will be removed, like some cells or like sub matrix or the subgrid will be removed. So the game will end when there will be a single cell. So I want to minimize the number of moves to reach the end state of the game, and the player B wants to maximize the number of moves that will be taken throughout the game. So problem statement should be clear. We have invested significant time in problem statement. So let's see some test cases. Okay, so this test case. So we have N, M, A, and B. So N and M is the size of the grid, and A and B is the position where the monster is situated in the beginning. So for the very first test case, we have 2 comma 2 and 1 comma 1. Okay, we have grid. We have grid of size 2 comma 2. Okay, it's 4 comma 4. Okay, and let's say the monster is placed where? The monster is placed here, 1 comma 1. So the monster is here. So the monster is here. Okay, so now it's my turn. what I supposed to do? I want to minimize the number of moves that will be taken throughout the game. Okay, so what should I do? What should I do? Okay, let's say I make a cut here. I make the cut here. Now this part will be removed. Now this part will be removed. This is the remaining grid. Now it's the opponent turn. Now either he can move this monster to this cell or he can choose to keep this monster in the same cell. Let's say he choose to keep this monster in the same cell. Now again it's my turn. The second cut I will be making is this. Now this cell will be removed. So how many moves we have seen? So guys, we have seen 2 moves. We have seen 2 moves. Okay. So for this test case, the answer should be 2. So here the answer is 2. Okay, so let's go for this test case 3, 3 and 2, 2. Okay. So 3, 3 was the size of the grid and monster is placed here. Okay guys. So now it's my turn. So I want to minimize the number of moves throughout the game. So I will be making the cut here. So I will make a cut here. So now this part will be removed. So now it's opponent's turn, and let's say he choose to make some changes to the position of the monster, and he choose to reposition the monster to this cell. Okay. So now again it's my turn. So I will be removing. Okay. So I will be removing this portion. Let's say I will be removing this portion. This portion will be removed. That was the second move. Now again it's opponent's turn. So let's say he choose to keep the monster in the same cell because it doesn't matter, actually it's symmetric whether you put the monster here, there or anywhere. So I will simply make the third move, and obviously the fourth move will be this. There is no matter where the opponents put the monster. So we have seen the 4 moves. So there were 4 moves. Okay. Now let's take a generic case. Let's take up the generic case. So we have seen 2 test cases. We have understood the problem statement. Now let's jump to the generic case. Okay, we have the grids. We have this grid. I don't know, it is m, m grid. And for some reason, guys, I have given the monster position here. Now, what are the possible cuts that I can make in order to minimize the number of moves? Guys, you tell me, if I want to minimize the number of moves, whether I will make a cut here. Why would I make a cut here? Why? Let's talk about the optimality. Whether it would be optimal to make the cut in the grid which is far from the monster's position. That will not be optimal, that we can see intuitively, because the agenda is to minimize the number of moves. So I will be making the cut near to the monster cell. So let's say this is the monster cell. So here I can make the cut. But now the question arises, where to make a cut? There are 4 possibilities. I can make the cut here. I can make the cut here. I can make the cut here. And I can make the cut here. So there are 4 possibilities I can make 4 cuts. Now, which of the cut will be optimal? Which of the cut will be optimal? Or we should try each and every possible cut, and whichever cut will give us the minimum moves, we will be taking that cut only. So we have two options. First option is to figure out which cut we should choose. There are 4 cuts and we're supposed to take one cut, but now again we have to think in the direction like which cut is to take, or like the brute force or the chill way, like we will be making all the 4 cuts, we will be trying all the 4 possibilities. That's the brute force method, and whichever possibility will be giving the minimum moves, we will be considering that possibility only. Now this depends on the complexity of the function that will tell the number of moves. If the function which will give me the number of moves is of time complexity of what? Let's say log n only. Like we can afford log n, guys, because it's already 10 is to the power 4, and so we cannot afford an order of n or a square root n complexity. No, the only complexity that we can afford is order of log n and log n log m. Okay, so let's see if we can achieve this. Let's see if we can achieve this. Okay, so guys, you tell me if so I am making the cut near the monster. So after the cut, where the x will be placed? After the cut, x will be placed either here or here or here or here or here, like on the edges of the boundary, only on the edges of the grid, because I am making the cut in a way that after making the cut, the x will be on either of the 4 boundary of the grid. So this is the move that I have made. Now comes to the opponent part. Like in terms of maximizing the moves, where you guys would like to place the x? You know, the current x is placed somewhere here or here, and you want to maximize the number of moves. Where you would place the x? Would you place the x on the edge? Because if you do so, I will make the cut here, and now this very big part or the big portion of the grid will be removed, and the game will be in my favor. But this is mentioned in the problem statement that both players are playing optimally. If both play optimally, as we can see. So the optimal decision would be to place the monster to the center cell, to the central cell of the grid. Now if it is placed at n, mth cell, then I will be placing the x to the central cell, and the central cell would be n by 2 or m by 2. Let's say this cell is, or let's say here, if I am here or anywhere in the cell, so I will be placing the monster to n by 2 comma m by 2 cell. So I want to convey this visualization that what I am doing, I am making the cut to the, which I am making the cut nearest to the monster. So after my cut, the monster will be on edge of the matrix. After my cut, this monster will be placed to the central pixel. Then I will be making the cut to the towards the central pixel. So in each iteration, I am making the cut in grid. So if the current size of the grid is nm, what you guys will be doing, you guys will be placing the monster from the boundary to the central cell, and the central cell would be the n by 2 m by 2, and then I will be making cut where? I will be making the cut towards the central pixel. Now this cut, I have told you already, there are 4 possibility of making the cut. But if n is greater than m, if n is greater than m, then of course I will not be making the cut in horizontal direction, because if n is greater, then of course it is optimal to make the cut to the dimension which is greater. If n is greater than m, then the next call would be to n by 2 comma m. And guys, if m is greater, then of course I will be making the cut to the horizontal direction if m is greater than m. So in each iteration, I am making one of the dimension, either the horizontal or vertical dimension, half of the current dimension. So if I am making the current dimension to be half of it in each and every iteration, so the complexity of this function would be log n. So if the complexity is log n, then we can afford to check each and every possibility. And I have told you guys there will be only 4 possibilities, because if x is there, then I can make 4 cuts. The first cut, or this cut, or this cut, or this cut. So there are 4 cuts, so we will be calculating for each and every possibility. And as we have seen that the function complexity would be log n. In each iteration, I will be picking the larger dimension and I will be splitting that dimension into the half, and so on. If both dimensions are equal, then I can choose any of them. So let's see the code. Okay. Okay, so this is the problem B solution. So this is the function, guys. So if a and b are 1, it means I am done. Like there is only one cell left, so I will be returning 0. If a is greater than 1, then I will be taking a plus 1 by 2. Guys, this a plus 1 by 2 is nothing but the seal of a by 2. The seal of a by 2. So guys, if we have 5 by 2, this grid, let's say, this is 1, 2, 3, 4, 5. So I will be making cut either here or here. So cut is I am making the cut towards or near 3, either second size or fourth size. After, if I make the cut here, then the remaining side will be this. So again, there will be 3 cells. If I will be making the cut here, then again there will be 3 cells containing 3, 4, and 5. So again, that's why I am taking the seal, which is a plus 1 by 2, because 5 plus 1 by 2, which is 6 by 2, that will be 3. And same, I'm thinking that if a is not greater than b must be greater or equal. So in that case, I'm making the function call for b plus 1 by 2. So that was a simple recursion, and the complexity of this recursion would be again logarithmic. And now here we are calculating this function. We are given a and b for all possible 4 scenarios. The first possible scenario will be n comma b, and the second scenario would be a comma m. Third would be n minus a plus 1. Like these are nothing but so let's say this is n comma m, and this particular portion till here, this is b and this is a. So the first thing that you can do is either you can do a number of rows and b number of columns, or you can do no, you're supposed to pick any one dimension. Like you cannot take both directions. So a number of rows and m number of columns. So a comma m. So that will be this portion. So this will be this portion, this whole portion. Or you can take n comma b, so n number of rows and b number of columns, so this will be this portion, this whole portion. And another thing that you can take is n minus a plus 1 comma m. So guys, this would be your this portion. and the last portion will be this portion, and that would be your n into m minus b plus 1. That will be your this portion. So we will be looping. We will be calculating that function for all the four possibilities, and whichever will be giving the minimum, I will be adding one, because again you are making this first cut here. So 1 plus that possibility will be the answer. Okay, so we are done with the first and the second problem. The first and second problem was good. Now let's see the C1, the third problem. So you guys must have put significant efforts and brainstorming in this problem. But when I will be telling you the solution of this problem, you guys will be very disheartened. You will be feeling, uh, you will feel the amount of regret, because the solution has nothing. It is actually, the solution of this problem will take less time than this first problem. So actually, it's not your fault, guys. If you are looking for DSA and if you are preparing for data structures and algorithm, if you are not into the comparative programming, then you must have not dive that deep into number theory and all. But that question is this C1 and C2 both C1 and C2 has the same solution, and this solution is all about this number theory. Uh, okay, so let's see this problem statement. Okay, so this is an interactive problem. So generally these kind of problems are not asked in the online assessments and the interviews. But again, these kind of problems test your problem solving in efficient manner. So the problem is that in this interactive challenge, there is an unknown integer x. Okay, so we have an integer x. We don't know this x. You must make it equal to given integer in input n. So like we supposed to make this x equal to n. Okay, and there are some commands. You can send a command, do one of the following. Like we can do any of these following to the x. Like there could be a x, and we can add, multiply, divide, or digit. Where this digit operation is a special operation. This will give you the sum of the digits of the x. As you can see, your x is positive initially, so the sum of the digits will always be positive. Okay, so we can add, multiply, and divide. We can do these kind of operation to x, and what we're supposed to do, we're supposed to make this x equal to n, and n is given to us. Okay, so we have seen the problem statement, like there is nothing in the problem statement. Now, what we can do, guys? Now, as you can see, the constraint is like we're supposed to do this thing in 7 commands. Like only 7 of these operations you can do. Okay, so how to proceed? Like what we should do, guys? Let's see, if x is 10 raised to the power 9 and there is this digit operation, so let's start with this digit operation. So the thing is, guys, if you perform digit, your number will become very small, isn't it? Like this is the thing that should strike your brain. That why this digit, like addition, multiplication, division, and then this digit. Why this digit? Because this digit operation will reduce the x with the great amount. So for example, let's say I have this huge number, say 9 up to 9 times. Let's say up to 9 times, because this x can go up to 10 raised to the power 9. So yes, this 999 will be, again there will be 9 digits, and in 10 raised to the power 9 there will be 10 digits. Isn't it, guys? In 10 raised to the power 9 there will be this 1 and 9 zeros, so there will be 10 digits. So the biggest number, the biggest digit sum that we can get is from this 9 nines, and the sum of the 9 nines would be 9 into 9, that is 81. So you see, from 999999999 281. This is the drop you will see if you apply this digit operation. So somehow I want to convert x into n. What I can do? I can do x plus a, and then I can do into b, and then I can divide by c, so that this will become n. And then how to find this a, b, and c? Like, this is not possible for me. Like, how? I don't know x. I know only n. How someone can supposed to find three unknown variables? So there's supposed to be a trick. And we are seeing that like this amount of drop. Like, so digit sum is for a reason. So that I have seen that this digit sum is for a reason. If I apply this digit sum to this number as well, then I will get 9. Okay. So the trick is, like, there is this trick. If you know, then you can solve this problem. If you don't know, then you can't. Like, there is no observation or something. If this trick strikes your brain, then you will be able to solve this. Otherwise, there is nothing you can do. So we have seen that there are 9 nines, and we can, if I apply 2-digit operations, this we have observed. If I can apply 2-digit operations, after applying 2-digit operation to any x, I will be getting a single digit. Isn't it, guys? That is the observation. Please respond. If I apply digit operation 2 times to any x, whether this x could be 1 or this x could be 9999999. After applying digit operation 2 times to the same x, I will end up in a single digit. Now this single digit could be 129. This single digit could be 129, isn't it, guys? Now it's, can I choose what this digit would be? The first thing that I have observed is this: if I apply digit operation to the x 2 times, I will end up in a single digit. Now the single digit would be 1 to n. Can I choose what this digit would be? Can I have this control? Yes, I have this control. I can make this digit to happen 9 every single time. I will do the magic so that the digit I will get will always be 9. How is it possible? How this magic can happen? So this is this simple number theory concept. If you have an x, if you multiply this x with 9, then you will be getting some integer y. Okay, this is the first thing. The second thing is this: if any number a is divisible by 9, then the sum of a will always be divisible by 9. Then the digit sum of a will always be divisible by 9. Will always be divisible by 9. Isn't it, guys? Let's say we have 18, then we have 27, and so on, then we have 81. You can see the sum is 9. If there exists any number which is divisible by 9, then sum of its digit will always be divisible by 9. So I have this x. I don't know what this x is. But if I multiply this x by 9, if I multiply the x by 9, I will be getting some y. Now I know this y is divisible by 9. The maximum value of x can have is 10 raised to the power 9. Or in terms of maximum digit, there will be 99999 and so on, 9 nines. So 9 into this thing will be, though the maximum value of y can have is 9 into 10 raised to the power 9. So guys, if I apply 2-digit operations on the y, guys, if I apply 2-digit operations on this y, I will end up in, what? I will end up in 9. I will end up in 9 only. Because we have seen, like, if we have this big number, of course this number is divisible by 9, and if I apply digit sum to it 2 times, I will end up in 9. This, I don't know what is the x, but I know if I multiply the x with the 9, then the resulting x will be greater than 0. So the resulting x will be divisible by 9, and if it is divisible by 9, then the digit sum of the updated x will be divisible by 9. So if I apply the digit operation 2 times on the updated x, I will end up in 9 only. Okay, so the first operation is multiply by 9. The second operation is take the digit. The third operation, again take the digit. So digit sum, multiply by 9, digit sum, digit sum. And now I know after these 3 operations, what I will be having? I will be having 9 only. And I want to convert this 9 into n. Then I will simply add. With what? With n minus 9. If I add, the answer of these 3 operations will be 9. 9 plus n minus 9 will be n only. So you're supposed to perform these 4 operations, and your C1 as well as C2 will be solved. Let's see the code. So here is the code, guys. Like, we have already seen this brute force or like the pseudo code sort of thing. So, like, of course, we will be providing the C++, Python, Java implementation of the code, and like there is nothing much in the like there is no computational or constructive problems in which the programming matters. Like, the problems were very intuitive. So if you know any programming language and its basics, so you will be able to solve this. Okay, 42. So let's see, we have 42. So let's say 42 into 9. So 9 to the 18, then 1, 9 fours are, guys, 9 4 would be what? Again, there would be 36 and 1 would be 37. So guys, 3 and 7 will be 10, 10 and 8 will be 18. So the digit sum on 3, 7, 8. So first multiplication. Okay, we are done with multiplication. Then digit sum of 3, 7, 18 will be 18. Then again digit sum of 18 will be 9. So after these 3 operations, I have this 9. And then whatever you give me, what any n, I will be doing this n minus 9, and then we'll be adding. Let's say you have n is equal to 100. So 100 minus 9 will be 91. So I will be adding 91 to the x. So I know my current x is 9 only. So 91 plus 9 will be giving you the 100 only. Simple as that. Okay, we have seen the code. Like, there is nothing in the code actually. Yeah, you're supposed to follow these rules. Yeah, like you're supposed to take take input, then you're supposed to output this, and the whole structure. But that is not the big deal. The whole logic, that was the main part that we have discussed already. So yeah, so this simply we are just multiplying with 9 and flushing the output, then taking the input, then again digit operation, and then again digit operation, and then simply adding m minus n. That's it. So that was for today, guys. We have covered A, B, C1 and C2, because in C1 we're supposed to solve this problem in 7 commands, but in C2, we're supposed to solve this problem in 4 commands, and we have seen the solution for the pro version, C2 version. So that's it for the today's session, guys. I hope you must have learned and you must have, yeah. So that was it, guys. Thank you.